Okay, so the first part of the distance matching section, I think we have covered this one, which is advancing the time by distance matching for start anim layer, right? So which means like at the start anim, now we doesn't have a foot sliding or explicit uh, time advancement based on each delta time. Instead, we drive our animation's speed alongside the bounce velocity by using the distance curve, right? You can see at the start, now it doesn't have any sort of foot slide. Okay, right. Now let's add distance matching for other states as well. Right. Now, since we covered the start anim, let's go to the cycle state. And here we have update cycle anim layer. And if you go there currently, currently we don't even advance in the time, right? Because actually we are simply playing this using a sequence player, therefore we are not advancing the explicit time. But still we can add the distance matching feature to manipulate the play rate actually, right? So if you remember at the start, inside here we are advancing the time actually, right? Because we are using a sequence evaluator, and inside the sequence evaluator at the start we are setting the explicit time as 0, which means we are pointing to a very first frame at the 0 time, and when the frame is getting rendered with the time, we are calling this on update function. So for each frame render, we are simply advancing the time using distance matching, right? But that can be done whenever we are using the sequence evaluator. But if you are using the sequence player, now we don't have explicit time. Instead, what we can do is we can manipulate the play rate, right? So it will be like similar to the advancing the time. Okay. Now I'll add sort of a space here, and let's get the return value of this set sequence with inertial blending, and I'll set the play rate to match speed. Right, again this one comes with distance matching library, right? Okay, and for the speed to match we need displacement speed, right? And this variable actually comes from update location data, right? So here we simply calculate displacement speed based on the displacement since last update and the delta time, right? So we have this displacement speed, and as usual we need to determine this play rate clamp. So since this is a cycle anim, I will use the play rate clamp cycle. Okay, all good. Now let's play test. Okay, now we are entering to the cycle anim. You can see 0 foot sliding is there. It's exactly the animation frame match with the bounce velocity, right? It's very neat and pretty much realistic. Okay, great. Right, now let's apply the distance matching for stop. So I'll go to stop. Right, here we are using sequence evaluator, so obviously at the on update time we are advancing the time. right? Mm, but before going to the update, let's look at the setup stop anim layer function. Okay, we have this set explicit time at here. Now the issue is like it's not quite good to set explicit time as 0 for the stop anim layer, because what will happen is like since we inherit a sort of a speed at the cycle level, maybe based on that velocity variation, we need to play a specific frame instead of always playing the very first frame of the stop animation, right? I hope what you get what I'm meaning. Like, for example, let's say maybe we are stopping at, for example, let's say 100 velocity point. Maybe we are stopping at, let's say, 80 velocity speed. So based on that variation, we should point for a specific frame at the stop animation instead of always playing the very first frame onward. Okay. So let's get rid of this set explicit time, right? And yeah, maybe let's keep the set explicit time for a moment. But first, let's check whether we can do the distance matching or not. Right? So in order to do that, I can create a new function, and I'll name this as should distance match stop. Maybe I'll create a new category called distance matching. A small typo, distance matching. And this should be a thread safe function, and I can make it as a pure function as well. Okay, right. Now let's first check whether we have velocity and what? And let's say whether we have a proper actually we can get the property access pin as well. And let's first check whether we are locally controlling or not. Okay, actually this stuff comes handy when we are doing sort of like a multiplayer game, right? Because sometimes in the multiplayer games, to do a effective task, sometimes we need to get rid of these distance matching related features, right? At the server side, right? Instead of that, for the client side, we can do these distance matching related logics. So actually, to implement such logics, we need to first determine whether we are at the client side or the server side. So there is a pin called, or not a pin actually, function called is locally control, right? So this function can determine whether you are a client or a server. Right? If it is true, you are a client. If you are false, then you are a server, right? So actually, I will add these features for now at our should distance match stop function, but later on when we are applying some sort of like replications to have like a multiplayer, to make our game like multiplayer compatible, then these features will come handy, right? So let's add another property access pin and try get power owner. There is another function called has authority, right? has authority. Where is that function? Yeah, so, and let's say if either of them getting true, then based on that we can do a Boolean selection, right? This one maybe. So let's say if this one is true, then we consider the hash acceleration. If it is false, then we consider simply whether we can play the start anymore or not, right? And I'll get the not condition out of it and attach it to here, and let's return it like this. So this will simply do that calculation for us. Okay, now this can determine whether we should do a distance match stopped or not, right? So I'll go back to our origin function, and at here I'll add a condition and get this one, add it to here. And if we should do distance matching, then we can actually, if we shouldn't do distance matching, then we can attach our pin to here, right? Did I get it wrong? No, this one is false, and if it is true, let's do distance match to target. Okay, and I'll use the sequence evaluator node pointed from here, which is this one, and distance to target I'll keep it as 0 because obviously we are going to stop, so the distance to target should be 0. And as the distance curve, let's use the same curve that we used at the start state, which is curve locomotion distance curve. Okay, compile and save. Yeah, actually this should attach to one of the pins here. Let's play. Yeah, it's I think applying, but let's disable this one. No, I think this should comes at the false, right? And let's play it again. Yeah, I think I got the issue because we only set the very first frame at here, right? We should update it accordingly as well. So I will plug these like that we had before, compile and save, and let's go to the update stop anim layer function, right? Okay, so here we are simply advancing the time, right? Instead what we can do, we can apply the distance matching logics, but first we should check whether we should apply the distance matching or not. Therefore, let's add should distance matching stop here, and I'll add a branch. And if we are doing the distance matching, we apply those logics, otherwise we are applying these logic. So I'll keep the pins here for now, and let's first complete the distance match based path. Right, so we need to actually predict the stop distance, right? Otherwise we don't know at which distance this stop animation should be matched. Do we have a function called get predicted stop distance? We don't have it. So let's quickly create a new function called get predicted stop distance. Okay, then I'll move it to the distance matching category, and this should be also a pure function and thread safe. Also, this is a constant value, right? Because we are not going to modify these values either way. Okay, and at the animation locomotion library, provide this handy function called predict ground movement stop location, right? So actually this one is used to determine the stop location, but based on that, if I get the vector length based on the xy coordinates, I will get the stop distance, right? So I'll simply return the vector length of xy as the return value, so I'll get the predicted stop distance, right? But we need to plug these values now, right? So let's get the property access pin, and here we have get movement component, and we need this get last update velocity. Okay, and the next one, we have a boolean called b use separate braking factor, use separate braking friction actually. So use separate braking friction, and we need braking friction. We have what, get movement component and braking friction, and then we need ground friction, and braking friction factor, get movement component, braking friction factor, and finally movement component, braking deceleration. Okay, right. So all of these variables has been taken from the get movement component, and these are default variables provided by the Unreal Engine. Compile and save. Now this function can be used to predict the stop distance, right? So let's go to our update stop anim layer, and I'll get this predicted stop distance and promote it to a local variable called distance to match. Okay, and then if I have a possible distance to match, then I can apply the distance match to target, right? So let's take the pin called or function called distance match to target, and as the node I can attach this one here, but instead of dragging the pin to here, let's get the node, and let's convert to sequence evaluator and attach it to here. Okay, and as the distance to target, we can use this distance to match, and as the distance curve, we can use distance curve. Okay, and I'll attach the return pin to here, right? So this is the happy part, which means like if we have a possible distance match and if we should apply the distance match, then it will be applied, right? But let's say if we doesn't have a distance to match, or let's say if we doesn't need to apply the distance match, then it will simply use this advanced time mechanism, right? So I'll cut this pin and copy it to here and attach the node to here, and this one, let's set the reroute pin and connect it to this one as well, right? So if we shouldn't apply distance matching, or if the distance to match is less than 0, then we simply advance in the time. Okay, let's attach it to here, compile. Yeah, you have to attach the context pin as well. Compile and save, and let's play test it again. Okay, I think it has been applied. Right, so since we have a like sort of a small movement, right, I can see we have quick stop, right? But what if we go to the setup stop anim layer? Maybe I'll add the pin to here and compile, save, and let's try it again. Yeah. Yeah, maybe I'll keep the setting as before. But yeah, I think it works properly. Right? Right. So maybe I think since we have this walk speed as 500, it will check the distance curve at the stop, which is here. And since we have a smaller, not actually smaller, since we have a significant walk speed, it try to play from this sort of position onwards, right? Instead of going from here, right? For example, let's play test the walk speed, walk movement, right? So walk movement, you can see the stop is applying bit early, right? Because we have a lower speed actually, and the animation is syncing with this speed, right? We don't have the foot sliding like we had before, right? Okay, let's test the crouch. Yep, crouch also work. Let's test the jog again, and yeah, jog also work. Okay, right. So that's how we can apply for the distance matching for cycle and stop anim layers. So maybe at the third part, let's cover the distance matching for pivot states. Okay, I'll see you there, and thank you.